Hey everyone, we're going to do a quick unscripted follow-up to the PlayStation 5 thermal benchmarks. So we reached a wider audience with that doesn't really watch our content. Probably some of them didn't know we exist. And I'd like to try and help out by answering a couple of the questions that popped up from people who don't see all of our other content where we often address those same types of questions. So this is going to be in the Ask GN format with a very specific focus on the PS5 testing as a follow-up, going through mostly Reddit thread questions. Before that, this video is brought to you by Thermaltake's Core P3 case. The Core P3 is one of the most unique cases on the market. It can serve as an open-air standing chassis, a test bench in vertical or horizontal orientation, or as a wall-mounted showcase PC. The Core P3 now comes with a 5mm thick tempered glass panel for its side, but keeps the front, top, and back open for air. You can learn more at the link in the description below. So the first one, I saw a couple of people asking about, well, the thermal pads were like broken in the teardown of the PlayStation 5. Couple of things. First of all, the teardown shots we showed of the PS5 were after it had been disassembled and reassembled a few times. On first disassembly, the pads remained fully contiguous and were not a problem. And the reason they start to crack down the middle like that after multiple disassemblies is obviously because thermal pads are kind of greasy by nature. They're a little bit oily, and you start to lose some of that that sort of adhesion as you take apart a device multiple times. Actually, I've got a Radeon 6800 XT right next to me where the thermal pads are still in great shape after 2 full disassemblies, but over time they'll start to crack. So in the first round of testing, this is actually why we normally don't show the full test setup, because people will see stuff like this and then not understand what they're looking at or the context behind it. So we often hide the actual exact setup and placement of thermocouples because people just don't know what they're looking at and then try to make something out of it when they don't understand it. So the thermal pads remain together on that first disassembly. It's not really that big of a deal for them to survive one disassembly. Secondly, and I can prove this on our dummy heater setup, we'll cut to some footage of that. A crack in a thermal pad doesn't affect the performance in any meaningful way whatsoever. So you don't need to worry about that. As long as the thermal pad's still there, as long as it still forms a surface, there's still contact between the device being cooled and whatever the heatsink, or in this case heatsink, is, you're good to go. So a crack doesn't really change anything. What starts to matter is when it starts crumbling. If it's like this, the PlayStation 5 doesn't really have this type, but like on this Radeon card where they're not as oily, and they can start to crumble and literally like turn to dust almost as you mess with them more and more. So that's when it becomes a problem, but that is not a problem on the PS5. So crack in a thermal pad is worth less than a degree of difference when you're looking at the type of work we're doing. That said, once again, for initial teardown, they were fully intact. Also, not sure why people seem to not understand this, but we can replace thermal pads with like other ones that we have. I have a whole bunch of assorted thermal pads down there, all kinds of thermal conductivity, sizes, thicknesses. We can easily replace any of them. So not a concern, to answer that first one. Second question that we saw a lot was a good one, and one that we should have addressed in the content. The question was, what can I do? If I'm worried about the temperatures on the device, what can I do about it? So what you can do, or what you should do really with any device, regardless of its thermal performance, is place it somewhere that it's not going to suffocate. So game consoles often are shoved under a TV and a cabinet of sorts, and historically this has been not really the best decision either, but the consoles weren't always as high power consumption as they are today, and it's just with the size of these things now, they're taking up more of a sort of percentage of the space that people are shoving them into, and they pull more power, therefore generate more heat, and the cooling solutions aren't necessarily given the most access to air in those sort of home theater, home console, crammed together setups. The best thing you can do is get your device out where it can actually breathe, and it's not going to be constrained by some cubby or bookshelf or something like that. So try to give it access to air. This actually leads into another question that I wanted to address as well, and we'll give that a separate time bar. But another question that we saw was one of, what about a higher ambient temperature? That is a great question. Our testing environment is about 21 to 23 degrees Celsius for the test that we published for the PS5. And there are two things to look at here. One is that the fan PWM signal on most silicon most pieces of silicon being cooled by a fan connected via PWM at some point. That signal is typically controlled by the temperature of the primary device it's cooling, not the secondary or tertiary ones. So the SoC would be the primary device here, just like a GPU would be for this, where these fans will follow the temperature of the GPU as determined by vBIOS. So there's going to be a fan curve in vBIOS, and based on the GPU temperature target, those fans will ramp to meet that temperature target along the fan curve, the PWM curve in vBIOS. So that's how it works on a GPU. It's the same thing with a PS5. It's going to follow probably the SoC temperature. We don't have visibility into it. It's not something that Sony really allows you to get into, and it's a closed system. So there's not really a great way for us to determine for sure what it follows, but almost certainly it's the SoC temperature. Sony has said that it will be adjusting the fan speed post-launch. Cynically, we would assume that maybe they were going for a quieter reception, as in literally the reception of it was this device is quiet, and then they'll worry about ramping the fan speed to meet thermal demand later after the noise testing is done, but that's just being cynical about it. It might actually just be the case that they wanted to get the device into more hands to collect more data. Not really sure exactly. Either way, they said they're going to be adjusting the fan speed over time. So PWM ramp for the fans will probably follow the SoC. Point of this is to say that if your ambient temperature is higher, like say 30°C, your SoC will be running warmer, and so that fan will ramp along its own BIOS, its own firmware curve to meet that demand. Unfortunately, this happens in GPUs too. Memory is often not considered in the fan curve in a BIOS. Again, we don't know exactly how the PlayStation 5 is written, but traditionally, memory is not what's considered. It's the SoC or the GPU or the CPU temperature. And so because the fan is specifically only cooling really one side of the chassis, which is the SoC side, we can show some teardown footage of it. There's not really any air getting into the back side of it, which is just a steel plate of the chassis connecting to the top of the memory modules. Because that's the arrangement, if the fan ramps, it's mostly going to benefit the SoC, so there might be a disproportionate change where the SoC temperature comes down more proportional to ambient than the memory temperature does. Let's say for every 2 units of improvement that the SoC has, the memory maybe has 1 unit of improvement or something to that effect. So that's a potential concern. We talk about that in GPUs all the time, where you get into things like ICX sensors, which are just NTC thermistors on the board, and that's where those can become beneficial when you can write your firmware to also consider other thermistors. And there are internal memory temperature sensors as well, but typically they're not followed as a rule for PWM aggression. So that would be the end result of all this, is to say that if your ambient's higher, probably there's a BIOS ramp for the fan that will at least take care of the SoC. SoC temperatures looked okay though in our testing. We don't have any visibility further than what we could do because there's no tools to read the internal dye sensors, but it looked okay. So memory still remains a bit of a question mark there. And by nature of reducing the reverse side temperatures, the memory will run a little bit cooler, or at least maintain rough rank with where it is at a lower ambient, because you have to remember all these devices on the other side of the board are generating heat. The board is largely composed of copper for traces, and that's all going to sort of share the heat load between all the components on the board. So as you cool one half of it, the other half will naturally get a little bit of benefit there, but nowhere near the benefit that the primary side with the cooling fan on it and the heatsink on it would get. So you will have a disproportionate improvement in SoC temperature versus the memory temperature in the scenario where PWM ramp is based on or contingent upon the SoC thermals. So that's the unscripted answer to that one. Hopefully that helped make some sense. Basically, for the first part, don't trap your console in a small like cubby where it's going to run hot anyway. Not really great for it to begin with. And it might run louder as a result of that. If you notice yours is running a lot louder than your friends or something, there's a potential for it being more choked in its airflow, and so it's ramping the fan harder. Let's take the next one. This one says they are not measuring the temperature according to JEDEC JESD 402-1 standard. It should be on top center of the case surface. In 1955, can be spotted on another location on the side. Also, thermal material broken, already answered that. Just curious how relevant it is for acquiring good measurements. So the JetX standard is a silly thing to follow for this. There are a lot of reasons for that. If you are worried about a crack in a thermal pad, even though it makes still contiguous contact once sealed, and also it was contiguous, before we took it apart the third or fourth time. If you're worried about that, why are you not worried about putting a thermocouple in the top center of the module and interrupting the contact completely with the thermal pad? So we were extremely clear in the content, as in multiple times throughout the video, that we placed the thermocouples along the edge of the case, and that is therefore going to be a lower temperature than if you were to take the actual dye sensor. Further, the top center of the module is not actually where the silicon is. It is a flip chip BGA package, and so the silicon is going to be closer to the PCB than it will be to the top of the module. A long time ago, I used to take measurements of memory modules by planting a thermocouple on the top of the module between the thermal pads, and over time we found that taking a side casing measurement was more consistent and accurate and had less influence on the performance of the device. You want to get in there with as little influence to the performance natively as possible, obviously, because that's what you're testing. And taking a side case measurement helps with that because you're not interfering with the thermal pad's contact to the module. So whatever JetX recommends, cool, but it's not relevant here. And also, again, we were really clear about it, and if anything, the temperature is going to be higher once you get closer to the silicon. This one was sort of interesting and really speaks to the wider audience that we reached with the console piece. So there's one question, not sure if we're going to be able to find it because I wasn't able to just now, but right after posting it, there was a fairly highly ranked comment on one of many console forums that our content was shared to that said it's interesting that the performance improved with the side panels off, and they acted like this was a huge revelation, and why would this happen? How could possibly the side panels being off make it better and not in fact worse? Because they're designed to, I don't know, channel the airflow or whatever marketing Sony has put out there in the past. Our normal audience, you don't really need to watch this part, but removing panels almost universally will improve the performance of basically anything. So think of running your phone without the case on it. If you're not busy throwing it and nearly dropping it off the table like me, you take the case off and it's going to run better than it will with the case on there. Same for the chassis of the phone. And the same goes for a computer. You take the front panel off, it breathes a lot better. You take the side panel off, it can exhaust better. Now, there are some places where it will get worse. So if you think of a case that's designed specifically to be almost literally a wind tunnel front to back, high pressure flow, and you take a panel off, now you're going to be leaking air out the sides before it ever goes through the CPU tower cooler or whatever it is that it's cooling. So there are cases where the performance will be worse, of course, if you incorporate the panels into part of a design, especially dealing with high pressure where you're trying to funnel it into something really fast. Because now you've got air leaking out. As soon as it gets through the fan, it's going to find the path of least resistance to keep moving, and that might be not where you want it to go. Almost universally, though, with devices, electronic devices in general, removing panels will improve the thermal performance. Not always a great option because you might have dust issues now, or noise issues, or just practicality of having exposed fans, and maybe you have kids or pets or long hair. So in those scenarios, you need to obviously have something to kind of contain it so that it's not going to be an annoyance, a nuisance, or a hazard or something like that. But yes, generally speaking, removing panels will improve performance of most devices. It's not a revelation, and that's basically something we talk about in every case review that we do. And to just explain why, I guess, a little bit further, if you were to take an anemometer and stick it behind a fan, doesn't matter if it's squirrel cage or axial or whatever, you put the anemometer in the flow path of the fan and then you put a solid wall in front of it, you're going to notice a significantly lower reading of linear feet per minute flow on that anemometer than when you remove the panel. So we've actually done tests like this in the past where you'll see as, for example, in one that we did not too long ago, changing the front panel from a fairly solid panel to a mesh panel, there was a difference of 450 linear feet per minute flow with that particular setup, down to about just 170 or so. So there's a pretty big difference in flow. And then separately for the PlayStation, because it is a basically squirrel cage fan that's just exhausting out the back of near the rear side of the console. In that case, the panels also serve as a bit of an insulator for that heat. Okay, here's another one. There was a good amount of discussion of people worried about or postulating on the impact of performance by games that are, quote, more demanding. We saw this a lot. People were saying, well, this is just Astro's Playroom at launch. What happens when a more demanding title comes out? Generally speaking, as long as the power envelope remains about the same, they're going to be about the same thermally. There are cases where this isn't true. So, for example, you look at a workload like FurMark in the GPU space, which is specifically designed to be a power virus, really taxes the VRM, and you'll see a hotter VRM typically with FurMark than you might with something like a lesser workload, like a gaming workload that might be just more focused on, I don't know, memory or the GPU core or whatever. So there are places where the workload type will have a tangible, meaningful impact on the thermal performance of whatever you're measuring. But with a game console, for the most part, once you're at maximum power, which is about, in our testing, it was about 210 was the highest we saw in Astro's Playroom. We looked at some other tests people did, other publications did. It looks like no one was really seeing higher than 230 watts, and given that we're measuring it different ways, different countries in some cases, which does have an impact too, of course, that seems like a pretty reasonable difference, about a 20 watt difference. So as long as the device sticks to about that power envelope, then the thermals shouldn't change too much. Ultimately, the heat we're seeing on the memory, on the MOSFETs, on the SoC, it's all because of power, the amount of power each of those devices takes, and that shouldn't really change too much from one game to the next. This one was entertaining because this particular user said, there's absolutely nothing wrong with any of these temperatures. So we actually basically said that throughout the entire 37-minute video, with the exception of that one memory module. That's the one we were concerned about, but we never used any language to make a big deal out of it. It was actually extremely careful about what I said because I knew it was going out to a console community that doesn't normally watch us and isn't used to our content. So I was really careful about the phrasing with that. And yes, this user is correct. It's weird that they're being combative about it. But as we said in the content, the SoC, the VRM MOS temperature is actually pretty good for where we measured it. SoC temperature seems good for our level of insight to it. And noise levels were good. Power consumption is pretty impressive for the graphics output you get. That one memory module is the one that concerns us. But otherwise, yes, there's not a huge issue with most of the temperatures, which is what we said. Oh, I should point this out too. In the content, we said that it's possible or even likely that Sony may have gotten what's known as a letter of exception from the memory manufacturer that said that the memory is accepted from the normal operating TJ Maxx that you would see on a memory module sold just to anybody. So that typically involves some validation testing and means that they've determined, whether that's Sony or the memory manufacturer or the two of them jointly, that the memory is okay to operate at that temperature. We don't necessarily agree with that, just like we wouldn't with some of NVIDIA or AMD GPU memory temperatures in the testing we've done in the past. But it means that they've decided it's okay, and assuredly they've done a decent amount of testing. But that doesn't mean that it's a good design. And this is another interesting point where we saw some comments that were like, does this guy really think that Sony didn't think of this stuff? No, I didn't think that at all. I'm quite confident that Sony put a lot more time and discussion into the memory cooling and the cooling solution than I did testing. But that doesn't mean that Sony is infallible or that it made the best decisions. Assuredly, some engineer somewhere in the company was telling Sony and its management for this project, the PMs, that it should do more dedicated cooling for the memory modules, that it should have some sort of actual copper contacting the memory modules. Definitely someone internally was doing that, and that person has probably used our video as ammunition to say I was right, damn it, why didn't we do this? So I don't know why the console audience is so much more willing to accept what's just given to them and assume that there's no room to improve anything. It's very strange. We don't see that in the PC space, and it's a terrible mentality. It's a very Apple-like mentality where you're just like, yes, this is great. They've spent years testing this. There's no way there could be any problems. How could some YouTuber think that they know more? We don't think that we know more than Sony does. It's just that we happen to find a thing that could have been done better. And you should be giving them a pass for something that could have been done better. You always want the product to be the best it possibly can be, and sometimes you get procurement involved or someone who's doing, I'm trying to think of the correct phrasing for this that isn't condescending towards that job role, but someone whose job it is to down cost the components to maximize the profit. Let's go with that phrasing. Someone in there is doing that job, and that does mean making cuts in places. It might mean less copper. It might mean one fewer heat pipe that's not going to contact that sort of stray memory module out in orbit on its own. So always there's room for a company to improve. No, we don't think we know more than Sony does about the thermals of its device, but we just happen to find some places they could improve it. And Sony should improve it, and you should want them to improve it and sell the best possible version of their device. I'd like to address this one too. This is on the opposite side, where this person's like taking what we said and kind of going a little too far in the anti-Sony direction with it, where they're saying, so the question that was posed in the comments was, are these memory temperatures a reasonable concern as someone who will likely be using this console daily for the next 3-ish years? So excellent question from that person. The reply to it from someone on Reddit was yes, and then goes on to explain our testing environment. And they say, well, it doesn't mean your console is going to explode. It will severely reduce its lifespan, especially when compared to what properly cooled memory is like. So we don't actually know that, and specifically in our content, we made no such claims. So not sure where that came from, but it's sort of a dangerous, irresponsible thing to reply to someone's question with such a position of such authority and say it will, quote, severely reduce the lifespan. There's no evidence for that right now. So it's suboptimal, and it could be better, and it could have, as we said, some effect on the memory, either long-term or the early texture abnormalities that could maybe be caused by a clock issue, unstable clock, or temperature. We've certainly seen it on the 30 series cards where you run them too hot and they will do stuff like that, but that doesn't mean that's what's happening. It's just a potential hypothesis for what's happening. So it is irresponsible to say things like this particular commenter said, and the best thing to say is that no, we don't know for sure what the long-term impact is. However, assuredly Sony has at some point tested this, and whether or not their conclusions were driving planned obsolescence or were actually reasonable for long-term use, we don't know. We weren't in the boardroom for those meetings. But what we do know is that for the most part, it's okay. That one module is a concern. Is it a, quote, severe reduction in lifespan? Probably not. That's a little bit strong on the phrasing. And we have no such evidence to make that conclusion right now. So just generally speaking, posting with that sort of voice of authority is not the best thing to do unless you actually know. Here was one we got on Twitter. They were asking, should I cut holes in the steel chassis to accommodate some thermal adhesive and a heatsink? And that actually reminds me as well, someone was saying, as an engineer, the material on top of the memory looks to be a cured thermal compound. It's not, it's a thermal pad. But anyway, that's a different story. So the question of a couple people are asking, should they mod their console to try and deal with this early? Our opinion as people who are pretty happy to mod stuff is no. A large part of the appeal of a console is that it's a closed box. You have a warranty with it. It works basically as it should out of the box, and if it doesn't, then you go through the warranty process, and if it dies, you go through the warranty process. As soon as you start modding these things, you have no recourse to get it fixed if something else fails in the future. And the failure rate of these things presumably is not that high, but let's say you have a capacitor fail totally unrelated to your mod. What are you going to do now? Maybe you can replace the capacitor yourself. If you can do that, awesome. you're beyond this level of content anyway for what we're talking about today. But for the most part, our recommendation is a strong no. Don't mod it just for this. You're better off using it until you experience a problem. And if that happens, then go through the warranty process and get it replaced. That's how we deal with it. It's not worth cutting holes in the chassis and gluing heat sinks onto the modules when you're voiding any chance of a potential warranty, because that is a non-reversible change. As soon as you cut a hole in the chassis, that's it, you're done. You can't explain that one away. Oh, it came this way. They're not gonna believe that. So we'd suggest leaving it alone. Great question though. This question's interesting mostly because of the response to it. Someone on Reddit said, does it make sense to place two 120mm case fans to the left or right of the air intake? And someone replied and said, no. Positive pressure causes stagnant air, i.e. air which heats up. And then says the fan is more than capable and Sony can always release an update if they find it has to ramp. So they can always release an update if they find it has to ramp, definitely. The fan is more than capable. It can spin a lot faster. It doesn't mean it should spin at max speed, but it can spin faster. Definitely shouldn't spin max speed though. That would be a problem for noise. As for the rest of the answer to that, so if you want to place a 120mm fan near it, the place that makes the most sense would be basically as exhaust. You would put it at the back of the grill where sort of the rear, the power cable is and stuff like that, back side of the console where the grill is, where the hot air is coming out from that blower fan, or some of it anyway. It might make sense to put one there and use it as exhaust to stop the air from pooling near the console, especially if you have it in a cramped space. So you go full Linus and cut holes in the cupboard that you have under your TV like he does and put Noctua fans in it. That would certainly help if it's going to be crammed in a small space. Better to not cram it in a small space, but that's one solution. Or if it's not crammed in a small space, you could just use it to pull the heat away so it's not recirculated back in through the blower fan. That's not going to be a huge issue. We didn't really observe that as much of an issue, but it would benefit you a little bit. So to just answer a straight no, that's going to make it hotter, doesn't really make sense or take into account the different ways you could arrange the fans. It doesn't really make sense necessarily as intake. It could benefit you depending on where the console is positioned and its access to air. So you'll have to judge that. But if you're going to place a fan somewhere near it, then getting the hot air away from the system probably makes the most sense. Wouldn't have a huge impact on internal temperatures, but maybe a little bit. Last one I'm going to take is one that says, I would like to see some prolonged readings under normal gameplay of a demanding game as well. This is more like trying to emulate Prime 95 testing on a console, which doesn't reflect real usage on a console much. It was a game. Prime 95 is extremely different from this. So typically with Prime 95, you're looking at, in non-26.6, you're looking at pure AVX workloads, and those kind of simulate like Blender to some extent, but you'd really be better off using Blender for that. It is not like a game though. So this is nothing like trying to simulate Prime 95 on a console, because we're using a game that is on the console that you can play for hours at a time if you'd like. So the prolonged readings we did were for an hour at a time. That is far more than enough to reach steady state. In fact, you can see steady state was often reached around the middle of the cycle. So you don't actually need to even be playing that long to hit those peak temperatures, but we allow extra time to hit steady state. And then the cooldown period was interesting to look at too. So as for, it goes back to what we said earlier, where what really matters is the power going through the devices. And if you're playing a game nonstop, aside from loading screens every now and then, which will give you a little bit of reprieve for the thermals, for the most part, you'll be at a steady state thermal for whatever component you might be thinking about. So whether that's SoC or memory, it's going to be basically a flat line if you're playing a game nonstop, except for those cases where you might say quit out to the menu and then come back later or something, which we tested for as well. So yeah, for the most part, the game shouldn't matter a whole lot. It might be worse in some cases than what we tested, but Astro's Playroom it's a real game. It's on the console. It seems to peak it to the max power consumption. That should get you about to the same level of power consumed by Red Dead 2 or whatever other game you want to talk about. So the components might be used a little differently. The amount of memory might be different, but for the most part, the amount of power is going to be about the same, or insignificant enough of a change that it doesn't matter. So hopefully that helps clear some of those up. It's probably not. It was a really wide audience, and this video is not going to reach any of those people, but hopefully a couple of you have stuck around and found it interesting content. And yeah, check back for more. We'll eventually be working on the Xbox Series X as soon as we can find some time. But we got to finish up some 6800 XT stuff first. Thanks for watching. Subscribe for more. We'll see you all next time.